Hello everyone, my name is William again, and welcome back to Unity, making a 2D platformer in Unity. And today what we're going to do is we're going to make a shooting mechanism, which I'm sure many of you will use in many good platformers. So what we're going to want to do now is we're going to want to go to the player, and we're going to want to add another empty object. And we're going to want to create this fire pause. There we go. Now let's give this, has a green dot. Then we want to push this over here. Let's make it 0.2. There we go. And now the problem is, if we play it, then this will always be on this side. What if we wanted to move here? Then we want to rotate the player. We want the player to rotate by 180. And the reason for this is twofold. We're not just doing this so that way we can put this over there. We also want to do this because, what if we want to make a rotate animation? You don't want to completely make a new animation for left-right rotation. So what we want to do is we want to go into the code for the player controller, and what we want to do is we want to actually make a new public function for rotating. So what we want to do here is you want to rotate it based on the speed. So if the rigid body 2D dot velocity dot x is greater than or equal to 0.1 f, so we're going right essentially. Now we want to do is we want to make a temporary rotation with a quaternion. By the way, don't mess with quaternions unless you know what you're doing, because they're much more complex than Euler angles. So temporod is equal to quaternion dot identity, which is just the rotation of this object. And then we're going to do temprot dot Euler angles, which are essentially 0 to 360, that's the Euler angles, is equal to vector 3 dot 0, because of this right is just 0 0 0. And then transform dot rotation is equal to temprot. And then we want to do, but this is another thing, if we change the rotation, then what happens is, what about these things, the left check and the right check? Well, they're going to actually change too, of course. So if we want to do other things, if we don't want them to be messed up, such as for things like wall jumping, then we have to change their position too. So left check dot transform dot position. We got to set the local position. The local position is pretty much the position in the when it's compared to the parent. So as you can see, its real position is not negative 0.125. If we were to take it out, it would actually be negative 5.3, but since it's relative to the parent it's in, well, that's why we do that. Anyway, so let's go back here, and the local position is equal to new vector 3 negative 0.125 f 0f 0f, and then we'll do the same thing for the right one. And then we're going to do an else if. So else if the rigid body 2D dot velocity dot x is less than or equal to negative 0.1 f. So if we're going into a negative route, then we're just going to do all this with some changes, such as is equal to, instead of vector 0 is equal to new vector 3 0f 0f and then 180f. Then we're going to set these to the opposite sign, so 0 to positive there, negative there. Then we're going to go back here. Then we're going to play. And then we're going to watch what happens. See, look, I move left and... Hold on, oh, we didn't call... Sorry, I have a bad habit of not calling functions. Sorry, my mind is preoccupied with other things. So let's check the left check. And as we can see, the position actually changes. So, look. The fire position is here right now. So that's how that works.